Lesson 8.2, Two-Way Tables and Probability. A two-way table is a way to display data from one source that belongs to two different categories. For example, here we have class and attendance for some event. So you have the freshmen, sophomores attending or not attending. The entries are called joint frequencies. So how many freshmen are attending? It's called a joint frequency. The totals are marginal frequencies. So we could make a box down here and we could say 25 plus 80 is 105. So there's 105 total attending, and 76, the 44 plus 32, that are not attending. You can make a box at the end, say 25 plus 44 makes 69 total freshmen, and 80 plus 32 is 112 total sophomores. Those are the marginal frequencies. Those and those. All right, let's say there are 16 juniors and 24 seniors on a debate team. Of those, 7 juniors and 19 seniors qualify for a state debate competition. Organize this information in a two-way table and find and interpret the marginal frequencies. All right, so we have total of 16 juniors and 24 seniors. 7 of those juniors qualified and 19 seniors qualified. So that's all the numbers we have. We can figure out the rest. To get the not qualified juniors, do 16 minus the 7, be 9 not qualified. And for the seniors, you do 24 minus 19 to get 5 seniors that didn't qualify. And then to get the totals at the bottom, add straight down. 7 plus 19 would be 26 total qualified. 9 plus 5 is 14. Did not qualify. Add those together, and it appears like you get 40 total students on the debate team. So interpret it. 26 total students qualified, 14 did not. There's 16 total juniors, 24 total seniors on the debate team. Total 40 total students on the debate team. Why don't you try number 3? All right, we also have what are called relative frequencies. A joint relative frequency would be the ratio of the joint frequency to the total values. Remember in your two-way table, it looks something like this, where we have our totals out here at the end. The numbers there were the joint frequencies. So when you divide by the total, you get a joint relative frequency. A marginal relative frequency would be the sum of the joint relative frequencies in a row or column. So to get the marginal relative frequency, just add across or add down. So let's make a table showing our relative frequencies. So what we're going to do is we can just do this by dividing them all by the total. So our grand total is 40. So we can just divide these all by 40. There's a new chart. So we have 7 divided by 40 for the juniors who qualified, or 0.175. Juniors who didn't qualify, the 9 over 40 would be 0.225. And our total juniors would be 16 out of 40, or 0.4. So in other words, 40% of the team is juniors. For the seniors who qualified, would be 19 over 40, which is 0.475. Seniors who didn't qualify would be 5 over 40, which is 0.125. Add those together, it'd be the same as the 24 over 40, which is 0.6. And then for the totals, you can either add down or just divide by 40. You get 0.65. If you add down, you get 0.35. When you add down or add across, you get 1. This should always be 1 when you're doing relative frequencies. Or in other words, 100%. All right, pause this and you try number 5. And then check your answer in the back of the book. We also have what are called conditional relative frequencies, which is the ratio of a joint relative frequency to the marginal relative frequency. So in other words, you have the squares in the middle, and then you have the totals on the outside. So it's one of these divided by one of these, or maybe it's the bottom. So we can do it for a row or a column total, so it's the inside square divided by its total of the row or the column. For example, let's make a two-way table that shows the conditional relative frequencies based on the row totals. Okay, so I have a new chart here. So based on the row totals, so the row total will be 16 here. So for the juniors, it'd be 7 over 16, which is about 0.438. And the not qualified juniors be 9 out of 16, or 0.563. So that tells us the percents of probability that a junior qualified or didn't qualify. For the seniors, the total is 24. So it'd be 19 over 24 for the seniors who qualified, or about 0.792. Seniors who didn't qualify, 5 over the 24 seniors, or 0.208. See, we divided by the row total, so we didn't divide by the same thing. And so that tells us that the seniors, you can see, are far more likely to have qualified than the juniors to have qualified. Why don't you pause this, try number 7, and then check the answer in the back.